we are going to construct a tangent. We are going to construct a tangent to a circle on a given point. But the problem is, we have a circle and we have a point. The only problem is we don't know the center. So we need to find the center, because to construct a tangent we need a radius. So how will you get the radius? We must need a center. But here there is no center. So we need to locate the center first. Okay? So let's start. What are the ways, or what is the way to find the center? Okay? So to do that, so here our objective is what? We need to find the center. Okay? We need to find the center when the center is unknown, when the center is not given. Okay? So first I will explain the procedure to find the center, and after that you know how to construct a tangent if the center is known. Okay? So let's start this. So to find the center on the circle, anywhere, you draw a chord. So I am going to draw a chord here. So this is the, what is this? This is the chord. So what do you mean by chord? A line segment which joins any 2 points on the circle. So I name this chord as AB. Okay? Actually, we need to draw 2 chords. But the condition for drawing these 2 chords is these 2 chords should not be parallel. So non-parallel 2 chords we need to draw it. What we need to do? Non-parallel 2 chords. So I am going to draw another chord which is not parallel to the AB. So what do you mean by non-parallel? That must intersect. So I am going to draw another chord in such a way that it is intersecting the given chord. So what is this, Nana? CD. So CD is what? Chord. What is the relationship between AB and CD? Therefore they are non-parallel chords. Okay, so this is the one condition that you need to keep it in the mind when you are drawing the chords for locating the center. Okay, so AB and CD are 2 non-parallel chords. Okay, so did you get our answer? No. Okay, did you get your center? No. Okay, so now to get the center, what we need to do? We need to draw a perpendicular bisector first. Perpendicular bisectors for AB and CD. Okay, so first I would like to draw a perpendicular bisector. Perpendicular bisector. So what is the condition to draw a perpendicular bisector? We need to draw more than one arc. Draw an arc above. Okay, draw an arc above and below, just like this. With center A. Yes, sir. With center A. Now come back to this side. With center B. Keep the pointer of the compass at B and draw an arc above as well as below. There is a one more. See, it will come up sometime. Yeah. So now, if you observe here, okay, for your better view, and drawing once again. It will come. Let's wait. Hold it for some time.
Sir?
Hold it for some time. Open. It is visible. Okay, this is how it works. Okay, and this is where. Okay, so these are the intersection points of A and CD. On the fan. So join these 2 points now. Join this 2 points. 2 intersection points. Are intersection points. Okay. You're getting a little different. No problem. So let's this. Right. So what we got? We got one perpendicular bisector of what? AB. Okay. What is the next thing we need to do? CD. Okay. So let's go to CD. Same process and more than a half a distance. Hey, this is the way to behave, right? So draw an arc above. Draw an arc below. Okay, let's draw. little bigger. Now come back to C.
CD.
Draw an arc here. Draw an arc here. So if you observe here, these two arcs are intersecting, right?
Yes.
Now take a big scale, okay, and join these two intersection points. So which gives the perpendicular bisector of C. Yeah. Now the perpendicular bisector of AB and the perpendicular bisector of CD are intersecting at one point. Okay. So what is this point? Intersection. The intersection point of the perpendicular bisectors of non-parallel chords is the center of a circle. Okay. So this is how we can locate the center. Now the next thing is as usual. Okay. We'll continue here. Okay. We'll continue till you get the tangent. So next what to do? We need to join O and P, right?
Yes.
Okay, now our actual task is started. What is our actual task? We need to construct the tangent at P. Okay, so to do that, what we need to do? First, we need to join O and P. So I am going to join this O and P because I know the center. So I can join this O and P. So that's your O and P. Next, what we need to do? We need to construct a tangent, right?
Yes.
Yes. I mean, what is this OP?
Radius.
And according to the converse of tangent, theorem 9.1. Yes, sir. So what is the converse of theorem 9.1? Line. Okay. A line which is drawn perpendicular to the radius of a circle is the tangent of a circle. Okay. If a line is drawn perpendicular to the end of the radius, end point of the radius, okay, is what? The line is going to become what? Okay, so this is what the converse of theorem 9.1. Okay, so we are going to use that technique here. So what do you mean by this? At OP we need to draw a perpendicular line. Okay, so now to draw a perpendicular line, we don't have a straight way to draw a perpendicular line.
Yes, sir.
So what we need to do? The only thing, or only way to get the perpendicular bisector is we need to find the perpendicular. Sorry, if you wanted to draw a perpendicular, we don't have a straight way to draw a perpendicular. We have only one way, that is perpendicular bisector.
Yes, sir.
So how can I get this perpendicular bisector at P? I need to see at P we need to get a perpendicular bisector. So I have to extend the P, right? Otherwise you can't get the perpendicular bisector. So to do that, give me some space. So let's take some imaginary line up to okay. So generally imaginary lines are represented with what? Dotted lines. So this is your x line. Okay, what is this? X. Okay, now come back. So what to do? Go to P with your comfortable radius. Okay, with your comfortable radius, draw an arc. Okay, you need to draw an arc or let the arc intersect PX as well as OP. Okay, actually take a little smaller so that it will be easy for you. Otherwise you will confuse. So I am going to draw two arcs, and where the arcs are intersecting at OP side, that is at radius side, and at PX side also. Okay, so remove this one. I changed it here, right? Radius. So now, what is this point, Snana? Let's keep these 2 points as okay. Already we have used an AB and CD. Let's use some extend via ML. So this point is L and M. Next, what to do? Next, we need to come at L side. Okay, with your comfortable radius. Okay, draw an arc above and below. And same process you need to continue from point M. Point M. So here and here. So now we are getting the intersection point. I mean, the arcs are going to be intersected, right?
Yes.
So let's join these 2 intersection points. Let it little here. Is it visible?
Yes, sir.
So I am not drawing once again. So you have clear visibility. Okay, now what we need to do?
Join
Join this. See, this is the reason why we need to take a bigger scale. Okay. Come.
Sir.
Scale ka chinna nam dikante. So now draw this line nana. Okay, if you observe here, what is this nana? Is it not line? What type of line it is? First perpendicular line for OP. OX. Okay, for OP or OX, it is a perpendicular line. And this perpendicular line is passing through which point? Point P, right?
Yes.
But what is OP?
Radius.
That means this is radius, this is line. So this line is perpendicular to this radius.
Yes, sir.
Here the line, okay, which is perpendicular to the end of the radius. See, end point of the radius.
Yes, sir.
Then automatically this line will be
Tangent.
So that is your theorem 9.1.
Yes, sir.
Converse
sir.
of theorem 9.1.
Yes, sir.
Yes.
So now it is not just a line, perpendicular line. It will be acted as what?
Tangent.
And if you observe closely,
Tangent.
okay, this line is going to touch the circle only at one point.
Yes,
Sir.
sir.
So therefore, the line touches the circle only at one
Only
point.
one
What do you
point.
call
Only
it?
one.
Tangent.
So have you successfully constructed a tangent?
Yes.
Here, this is a two-way procedure. First, we don't know the center and we located the center. And afterwards, we constructed the tangent.
Tangent.
Okay. So this is one way. There is another way also. Okay. So we'll see the other way also. But this is the basic way of constructing a tangent when the center is not.
Not.
Okay. So that's all. I hope you understood.
Yes.